Good evening, my dear children. Our next topic to learn about the Schrodinger wave equation. Schrodinger wave equation. Before that, some of them are not wrote the assignment. I am writing your name and I will call you back. Okay? So all the day you should be write the assignment. Some of them are not checking your answer. And not get signature from your parents. Please kindly check your answer after getting your sign, parents' signature. Then only you send to me, okay, your assignment. Okay? Okay. Quantum mechanical model of an atom. We are learning about the Schrodinger wave equation. First of all, what is about the Schrodinger wave equation? Here, for what purpose quantum mechanics is developed? For what purpose? In our small classes, we know about Newton's third law of motion. What is about the Newton's third law of motion? Is all of you know, am I right? Newton's third law of motion tells about motion of an object. That is called classical mechanics. In the classical mechanics, physical states of the particle determined by its position and the momentum that predict the future state of the particles based on the force acting on it. All of you know about the Heisenberg uncertainty principle. Am I right? What is about the Heisenberg uncertainty principle? It is impossible to measure simultaneously both the position and the momentum of the particles. Am I right? Of a microscopic particles. According to Heisenberg uncertainty principle, the position and the momentum of the particle cannot be measured correctly for the microscopic particle of an electron. In classical mechanics, does not consider the dual nature of microscopic particle. So, based on the Heisenberg uncertainty principle and the dual nature of microscopic particle, a new mechanism called quantum mechanics was developed. Next about the Schrodinger wave equation. Even Schrodinger expressed the wave nature of electron in terms of differential equation. This equation determines the change of wave function in a space depend on the field of the force on electron. This equation is a time-independent Schrodinger wave equation. Okay, let us discuss about the time-independent Schrodinger wave equation. All of you please take your note and listen the board. The Schrodinger wave equation can be expressed. The Schrodinger equation can be expressed as H cap psi equal to E psi. Okay? H cap psi is equal to E psi. This is one of the important question. Repeating board exam question. Okay? Now only all of you should learn this question. Okay? One of the very important questions. Here, one is about the H. H is called Hamiltonian operator. It determines the state of the system. Okay. Next about the psi. Psi is the wave function and is a function of position coordinates of the particle. It is denoted as psi into x, y and z, E. Where E is the energy of the system. Here, X, Y, Z Here the electron is an orbital by the 3D position. We are learning about the 1D, 2D. The next category is 3D. 3D means x-axis, y-axis and z-axis. The electrons are occupied in an orbital like that. Okay. Then we are using x, y and z. Here, the value of h. What is about the h cap value? H cap is equal to minus of h square divided by 8 pi square m. Clear? Into dou square by dou x square plus dou square by dou y square plus dou square by dou z square plus v. This is h cap value. First we should learn this one. H cap is equal to h cap psi is equal to E psi. What is about the h cap value? Minus of h square divided by 8 pi square m into dou square by dou x square plus dou square by dou y square plus dou square by dou z square plus v. Okay? Substitute this value to the equation. This is taken as the equation 1 to h cap. So we get minus of h square by 8 pi square m dou square by dou x square plus dou square by dou y square plus dou square by dou z square plus v into psi equal to E psi. Okay? Then for the h value we wrote here, h cap value we wrote here into psi equal to E psi. Any doubt? Have a doubt? No doubt. Next. Here, the next one step having that also should be right. Minus of h square by 8 pi square m divided by multiplied by psi dou square psi by dou x square plus dou square psi by dou z square plus dou y square plus dou square psi by dou z square plus v into psi v psi equal to E psi. Clear? Have it out? We are just multiplied by psi. For this time we are just multiplied by psi. Next time. Multiplying by this equation, multiply by minus 8 pi square m by h square. Okay? We have multiplied this equation by minus of 8 pi square m by h square. Okay? Multiply. So what is the answer? Minus of 8 pi square m divided by h square into minus h square divided by 8 pi square m dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. Okay, dou z square plus v psi into minus of 8 pi square m divided by h square. Okay, equal to E psi into minus of 8 pi square m divided by h square. So we can be, then we are cancelling. So what's the remaining answer? Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square into v psi into minus of 8 pi square m divided by h square equal to e psi into minus of 8 pi square m divided by h square. Okay, this term we are taking before the equal. Okay, so what is the above equation? What is the above equation? Can you say? Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square into v psi into minus of 8 pi square m divided by h square plus taking here before the equal. So what do you get? 8 pi square m divided by h square into e psi equal to 0. Clear? Clear? Okay. Here, next step is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. Okay. Into we are taking the common term. Okay, which are the common term? These are the common term. Okay, right, plus 8 pi square m divided by h square. Okay, 8 pi square m by h square e minus of v minus v common sign nothing commonly equal to 0. Clear? Have it out. Dou square psi by dou x square, dou square psi by dou y square, dou square psi by dou z square. I am taking this common factor. Okay, 8 pi square m divided by h square I am taking. Clear? Plus we are taking. Next of what? First I am taking this e minus of v common sign equal to 0. This is the expression. Okay? Okay? This is rearranging we get. What is the answer? Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square by h square e minus v psi equal to 0. This equation is Schrodinger wave equation, does not contain time as a variable and is referred to as a time independent Schrodinger wave equation. Clear? At least you should be learn the mathematical expression. Okay. If you are writing a 7 of the 3 mark question, if you are writing at least the expression, you can score full mark 3 out of 3. We are not expecting others, only this mathematical form. From beginning, cap h psi is equal to this equation. It's a very important question. Next topic above. What are the main features of the quantum mechanical model of an atom? What are the main features? I think that it have more than 4 or 5 points. Okay, at least you should be learned 3 points. The first point is the energy of an electron in an atom is quantized. The energy of an electron in atom is quantized. That is, it can be predict some value, the energy value. It can be predict. That's the first point. The second point, the solution of Schrodinger wave equation gives the allowed energy level. What's the second point? The solution of Schrodinger wave equation, the solution of Schrodinger wave equation gives the allowed energy level, have some allowed energy level, that is, we are saying orbitals. Okay. Next about the third point, the 2 point can be easily we can be learned. Third point, according to Heisenberg uncertainty principle, the exact position and the momentum of the electron cannot be determined with absolutely accuracy. Okay, we know that it cannot be determined accuracy. Okay, quantum mechanics introduce the concept of orbital. All of you know about the orbital definition. The orbital is the 3-dimensional space, am I right? In which the probability of finding the electron is maximum. Orbital is a 3-dimensional space in which the probability of finding the electron is maximum. That is about the third point. Okay. Next about the solution of Schrodinger wave equation for an allowed energy of an atom gives the wave function. It represents the atomic orbital. That is about the fourth point. And the fifth point is a small point. The wave function psi itself have no physical meaning. At least you should be right. Any 3 or 4 points is enough. Clear? Next about one of the question is about the quantum numbers. Quantum number. The electron in an atom can be characterized by 4 sets of quantum numbers. All of you know about the 4 sets of quantum numbers. One is what? Principal quantum numbers, azimuthal quantum number, magnetic quantum number, and spin quantum number. You have 4 types of quantum number. What are the 4 types of quantum number? Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. These are the 4 types. Here about the principal quantum numbers. The principal quantum number represent the energy level in which electrons are revolving around the nucleus. That is about the principal quantum number. It represents the energy level in which the electrons are revolving around the nucleus. It can be denoted by the symbol is N. That is a small n, not a capital N. It's a small n. That is all of you know that. Okay. The n have the value, some value. N is equal to maybe 1, 2, 3, 4, etc. Okay. Suppose the n is equal to 1, it represents the first orbit. We are seeing the shell, K shell, L shell, M shell, N shell, O shell, etc. Am I right? N we are saying like that, the first shell, K shell. Okay, how much electron can be occupied K shell, can you see? How much electron can be occupied in K shell? K shell, L shell, M shell, N shell, O shell. Can you see? That we can be find out one of the formula, the maximum electron can be accommodated by using one formula is called 2n square formula. 2n square. 2 into n square. 2 into n square. Am I right? N means number of orbit. K shell, L shell, M shell, N shell, O shell. First shell, we can be accommodate 2 electrons as per the 2n square formula. Second shell, 8 electrons. Third shell, 18 electrons. Am I right? We are calculating like that. That is 2 into 1 square. That is 2 electrons. 2 into 2 square. How much electron? 8 electrons. 2 into 3 square. 18 electrons. 2 into 4 square. That is 16 into 2. 32. 2 into 5 square. 5 square means 25. 25 to 2, 50, etc., etc., etc. We can be accommodate like that. Next about azimuthal corner number. Azimuthal corner number. It represents the letter by L. A small L we are using. It can take integral value from 0 to n minus 1. One of the value. What is the value? 0 to n minus 1. N minus 1. N minus 1. Am I right? Here n is the principal corner number. That is small n we are using. N is the principal corner number. Okay. And also it represents about the subshell. Subshell. What is about the subshell? Shell means that is about the principal corner number. Shell. K shell, L shell, M shell, N shell, O shell. These are all what? Principal corner number. What is about the subshell? What is about the subshell? S, P, D, F. Am I right? And one of the new term is also having G orbital. Am I right? Orbitals. S orbitals, P orbitals, D orbitals, F orbitals, and G orbitals. S subshell we can be accommodate 2 electrons. P subshell 6 electrons. D subshell 10 electrons. F subshell 14 electrons, and etc. Here the maximum number of electrons that can be accommodated by one of the formula in the subshell. One of the formula is 2 into 2L plus 1. What is the formula? 2 into 2L plus 1. What is the formula? 2 into 2L plus 1. That is the formula. The maximum number of electrons that can be accommodated given one of the formula is 2 into 2L plus 1 formula. In principal corner number, what is the maximum number of electron that can be accommodated the shell? What is the formula? 2n square formula. What is the formula? 2n square. Here what is the formula? 2 into 2l plus 1. What is the formula? 2 into 2n plus 1. That is the formula. Okay. Next about the magnetic quantum number. Magnetic quantum number. It is denoted by the symbol small m. Small m. It takes the integral value ranging from -1 to +1 through 0. Listen, one of the condition. What is the one of the condition? If L is equal to 1. L, what is the meaning of L? One of the condition. L is equal to 1. L is equal to 1. Azimuthal corner number is 1. Magnetic corner number is having 3 values. One is -1, 0, +1. Clear? What are the 3 values become? -1, 0, +1. The value of L is equal to 1. For example, P subshell. One subshell we have only one type of orbital. Am I right? P subshell can be classified into 3 types. 3 types. What are they? 2px, 2py, and 2pz. Am I right? One of the P subshell can be classified into 3 types. 3 orbital. One is 2px, 2py, and 2pz. The first one is what? -1. Second one is 0. Third one is +1. That is the condition. Okay. Here, different value of m for a given L value represent different orientation of the orbital. Different orientation. Having some spin about that orientation. Here, we are explaining one more concept. The Seaman effect provides the experimental value for the quantum numbers. Experimental value. We are giving some experimental value. Next about the spin quantum number. What is that? Spin quantum number. Spin quantum number. Spin quantum number. We are denoting the symbol S, small s. Some of them are using M, small s. That also you are using spin quantum number. Okay. Here the spin quantum number represents the spin of the electron. The electron is having some spin. It have maybe look upwards or moving downwards. There are some spin. The electron in an atom revolving around the nucleus. Am I right? Revolving around in the nucleus. But the nucleus, but also having some spin. We have some spin. The spin may be either in clockwise direction or either may be in anti-clockwise direction. The spin either may be clockwise direction or either may be an anti-clockwise direction. It have maximum two values. The spin have maximum two values are possible. One is minus half and another one is a plus half. Clear? One is a minus half and another one is a plus half. That is one of the orbital. The electrons are facing on the upward direction. We are saying clockwise direction. That we are giving plus half. Clockwise direction means plus half. Suppose the electrons are facing on the spin of the electron is facing on downwards. We are giving the values minus half. Okay? Then, about the quantum numbers of and its significance. Quantum numbers and its significance. Please all of you take the note and we can be calculate about the principal quantum number and the maximum number of electrons, etc. Please all of you take the note. First you take one tabular column, make it one tabular column. Okay? Tabular column. Okay? First you write the shell. You have the shell. Shell. Okay? The shell. Next about the principal quantum number. Principal quantum number. Principal quantum number. What is the symbol of principal quantum number? We are giving the symbol is n, small n, right? We are giving the small n. Okay, principal quantum number. Next about the maximum number of electron in the shell. In a shell, the maximum number of electron. Maximum number of electrons in the shell. What is the formula? In an orbital, 2n square orbital. Am I right? That's a formula. Azimuthal quantum number. Next one. Azimuthal quantum number. Here what symbol we are using? Small a. Okay. Here small n. Here small a. Here the value is equal to 0, 1, 2, 3, etc. Okay. Azimuthal quantum number. First one principal quantum number. Next one maximum number of electron in the shell, that is 2n square formula. Azimuthal quantum number. Then also having this also is one of the formula. Maximum number of electrons in an orbital. What's the formula? 2 into, what's the formula? 2 into 2L plus 1. That is the formula. What's the formula? 2 into 2L plus 1 formula. Next about magnetic quantum number. What are the magnetic quantum numbers? Okay, can I write? What is the quantum number? Maximum number of electrons. Azimuthal quantum number. Maximum number of electrons in orbital. Magnetic quantum number. Next about designation of orbital in the given cell. Designation. This is all everything having in our textbook. Okay, we can learn one by one. About the K cell, listen. About the K cell, first K cell, one by one we can write. Okay, K cell. K cell. The principal column number K cell, that is n is equal to 1. Am I right? N is equal to 1. It denotes K cell. Clear? N is equal to 2. It denotes L cell. N is equal to 3. It denotes M shell. N is equal to 4. It denotes N shell. N is equal to 5. It denotes O shell. Am I right? Like that. K shell. What is the principal column number? N is equal to 1. N is equal to 1. Clear? Next about, what is the maximum number of electrons in the shell formula? 2n square formula. Suppose n is equal to 1 means, how can you write the formula? 2 into 1 square is equal to 2 electrons. Am I right? The answer is 2. Next about the azimuthal column number, L is equal to 0. Here you should write, what is the formula here? What's the formula for azimuthal column number? We are writing the formula 1 minus 1. Okay, because the orbital is, we can give the formula n minus 1. N minus 1. Here n is the value is equal to 1. So n minus 1 means n is equal to 1. Am I right? 1 minus 1. So what is the value? Is equal to 0. 1 minus 1 is equal to 0. Clear? Clear? N minus 1 formula. N means principal column number. That is equal to value is how much? 1. 1 minus 1 is equal to 0. That's the answer. Can you write? Next about, what is the next one formula? The maximum number of electrons in an orbital? 2 into 2L plus 1. 2 into 2L plus 1. Am I right? 2 into 2L plus 1. Here. 2 into 2, L value is how much? 0. 2 into 0 plus 1. What is the answer? What is the answer? 2 into 0 is equal to 0. 0 plus 1 is equal to 1. So what is the answer? 2 into 1 is equal to how much? 2 into 1 is equal to, what is the answer? 2. Clear? 2 into 1 is equal to 2. Here, the maximum number of magnetic quantum numbers differ possible orientation. For 2, the differ possible orientation is 0. The orientation is 0 because it goes to the orbital, that is shell is called 1s. 1s. Okay. Okay. The 0 goes to what? 1s. 1s. The magnetic quantum numbers. Here the value is 0. Can you write? Can you write? Next about L shell. All of you know about that. K shell is equal to, that is n is equal to 1, it goes to K shell. N is equal to 2, it goes to L shell. Am I right? L shell. What is the formula? 2 into 2 square is equal to, 2 into 2 is, 2 square is equal to 4. Am I right? 2 into 4 is equal to 8. Clear? Okay. Next one. About the azimuthal quantum number, what is the formula? That is equal to n minus 1. What is the formula? N minus 1, that is the formula. N minus 1, that is the formula. N is equal to here what? First one. N is equal to 1 and n is equal to 2. Am I right? We are taking 2. First one is n is equal to, we are taking 1. 1 minus 1. What's the answer? 0. Clear? Next one. 2 minus 1 is equal to 1. There are 2 answers. Okay? The same like that for 0. What's the answer? 2 into 2, 0 plus 1. So what's the answer? 2 into 1 is equal to 2 answer. It's a 2 answer. Next about 2 into 2 into 1 plus 2. This 1 plus 2. So what's the answer? And plus 2 plus 1, okay? Here 1, so 1 answer. What's the answer? 2 into 1 is equal to 2. 2 plus 1 is equal to 3. Am I right? 2 into 1 is equal to 2. 2 plus 1 is equal to 3. So 2 into 3 is equal to answer 6. Okay? Answer 6. Okay, this also go to 0. 0 means L, for L cell it is for 2 years. L cell means it is for 2 years. Am I right? Next about here for L cell the value of L is equal to 1. It goes to the value I told you about that P subshell. About the P subshell 3 orbital. Am I right? 2px, 2py, 2pz. P orbital. Am I right? That is first one is what? Minus 1, 0, plus 1. Whatever 3 values becomes minus 1, 0, plus 1. 6 means it goes to what? P orbitals. Okay? 6 means what? This goes to P orbital. Which are the values comes? Minus 1, 0, plus 1. Okay? Here, what are the 3 orbitals? 2px, 2py, and 2pz. Clear? Have a doubt? No. If you have any doubt, means please contact me. Okay, I will help you. Okay. Next one. Find about the M shell. For the last one, I maybe give the assignment. Okay. If you have doubt, please call me. Next one is M shell. M shell. The principal quantum number is n is equal to 3. N is equal to 3. 3 value. So, as per the formula 2n square, we can written as 2 into 3 square. 2 into 3 square is equal to 9 is equal to 18 electrons. Am I right? 18 electrons. Okay. Here also we have classified into 3 types. Here also we have divided by 3 types. 1, 2, and 3. Which are the value? 1 is 0. Previously we discussed that one. 0. That is L minus 1. So 1 minus 1 is equal to 0. Second one. 2 minus 1 is equal to 1. 3 minus 1 is equal to 2. Next about for the 0 value already we wrote. What is the answer? 0 value. 0 value answer is 2 into 1. 2 into 1 is equal to 2. Alright? Next about 1 value. For the 1 value. That is 2 into 1 plus 1. What's the value? 2 plus 1. 3. 2 into 3 is equal to 6. Next one. For the 2 value. 2 into 2 plus 1. What's the value? 2 into 2 is equal to 4. 4 plus 1 is 5. 2 into 5 is equal to 10. Am I right? There. So, the first column 0 value we get 2. 1 value we get 6. And 2 value we get 10. There. Have it out? Okay. Suppose 0 value comes means, if 2 value comes means that is 0. 0 means oneness. Am I right? 6 means which are the value? 6 means which are the value? 2px, 2py and 2pz. Am I right? That means minus 1, 0, plus 1. Which are orbital? 2px, 2py, 2pz. These are the value. Next about 10 means it goes to D subshell. 10 means it goes to D subshell. Can you write the D subshell orbital? That means 5 orbital. We are taking 5 orbital. 1, 2, 3, 4, 5. One orbital we can accommodate 2 electrons. So 2, 4, 6, 8, 10. That's a 10. Am I right? For p orbital means 2, 4, 6. Okay, that is 6. For oneness we can accommodate 2 electrons. That is that. Okay. Then D. How will I take the d orbitals? D, x, y, z. First D multiplied with D. First D x into y. What's the answer? D x into y. D x into y. D x y. D x y. Then D x into z. What's the answer? X into z. D x z. Next D y into z. What is the answer? D y into z. D y z. Okay. Next about take this power. What's the answer? Dx square minus y square. Okay. Dx square minus y square. Dx square minus y square. Then close the x and y. What is the answer? Dz square. These are the 5 orbitals. Anyhow, 5 orbitals. Which are the 5 orbitals? First one dxy, dxz, dyz, dx square minus y square, dz square. Can you say which are the orbitals? dxy, dxz, dyz, dx square minus y square, and dz square. Okay. Then which are the values obtained? First start with minus 2, minus 1, 0, plus 1, plus 2. Which are the value? Start with minus. Minus 2, minus 1, 0, plus 1, plus 2. For p summation, minus 1, 0, plus 1. For d summation, minus 2, minus 1, 0, plus 1, plus 2. Which are the orbital? dxy, dxz, dyz, dx square minus y square, dz square. Say all of you orbital? dxz, dy, dxy, dxz, dyz, dx square minus y square, dz square. Okay. Now you write here minus 2, minus 1, 0, plus 1, plus 2. Okay. Which are the orbital? dxy, dxz, dyz, dx square minus y square, dz square. These are the orbitals. Clear? And the last one is n subshell. That also you should be take the return practice. Okay. If you have any doubt, means please call me. Please call me. Okay. Have any doubt, please call me. Okay. Anyhow, I am giving the assignment for the n shell. Okay. N shell is the assignment. It is not compulsory. Those who are interested, you can be right. Otherwise, please you learn for the tomorrow writing assignment. Please all of take the page number 43. Page number 43. Schrodinger wave equation. Okay. The mathematical expression is enough. Okay. Okay. Start with there. Here is Schrodinger, page number 43. The top of the page. Here is Schrodinger expressed up to the last paragraph, third line, okay. and is referred to as the time independent Schrodinger wave equation. That much, okay? I think that is a 3-mark question. One. Next about quantum numbers. Quantum numbers, page number. Quantum numbers, the page number is 44. Page number 44. There are 4 types: principal, azimuthal, magnetic, and spin quantum number. At least each topic, each subheading, you at least should be right. Select any 3 points. Okay, any 3 or 2 points. Okay, clear? Any 3. At least you should be select any 3 points. Clear? For tomorrow assignment, these 2 questions, all of you should write. And also, please, all of you, kindly cooperate to me out. And check the answer with the pencil. Okay, right? Whenever you are learning, you should be check the answer with the pencil and get signature from your parents. Okay, and send to me. Clear? Those who are interested, those who are studying more, those who are going to interest means you do the page number 46. Shell N. I completed up to N. That is K over L over M over and N only the balance. Those who are interested, you can do it at N1. Have any doubt, please contact me. Okay. Thank you all of you. Thank you. Have a nice day.